So good morning guys. So this channel is going to be a educational channel which is based on machine learning and deep learning, then optimization and probability techniques, and then we will move on to LLMs. So we will start with linear algebra as the first topic, and this is the first playlist which is going to be on the channel, and the topic for this playlist will be the linear algebra, the first stepping stone of machine learning, and also other dynamical systems, or you can also call it like linear algebra is the basis of like any mathematical or any scientific systems we see in today's world. So it's a actually every recommendation system, every AI model, every neural network, every optimization algorithms you see around, they all run on one invisible engine, and that engine is linear algebra. So the contents for this course will be, we will start with the basics of linear algebra, and after that we will move on to the fields, then we'll move to sets, then we'll move to vector spaces. After vector spaces we'll move to the eigenvalues and vectors, and we will actually intuitively understand what the meaning of eigenvalues and eigenvectors actually mean on the state space and on the coordinate geometry space. After that we will be moving to matrices, and then we may move to, so here also matrices, we will be understanding what exactly is the meaning of a matrix. So we all have known that matrices often mean that they are just a collection of values in a box form, but it's has got actually some more mathematical meaning to it. So we would understand that also. So basically then we will move to all kinds of transformations. And when I say this one topic, this is actually the base of linear algebra, and it's extremely important, and this is what gives the meaning of linear algebra. So linear algebra basically is a system of transforming linear equations onto the linear space. So it's a mapping between vector space and linear mappings of linear algebra and linear mappings between them. So we would learn about all the stuffs like what function is called linear, what is the meaning of linear, and then why some functions are not called linear. Actually, not some, most of the functions are not called linear, but still we always tend to make functions linear from non-linear systems because it is easy to calculate and they are easy to evaluate. So the world actually itself is a non-linear system. It's not a linear. Anything you see in this world is based of non-linear system, including our heartbeat. Okay, for a surprise, we can actually calculate the eigenvalues of our heartbeat, but we'll do those fun stuffs later in the course. But for now, actually, linear algebra, there are functions, most of the functions they are non-linear, but we convert them to linear, and then we like operate some kinds of operations on them. And because we do this, actually it is because that linear algebra, the in linear algebra, the things, the calculations become very much easier than non-linear system. For that matter, most of the non-linear systems are even non-solvable. So we just solve the non-linear systems, sometimes just around the equilibrium point, to just find the nature of the nonlinear system, or we just try to find the solutions by just finding the trajectories of the nonlinear system. But in general, when we linearize the function, we can actually infer a lot of information from the system. So we will be doing this all things, we'll be doing matrices, and then we'll be doing the applications of linear algebra. This is the most important. And applications, when we come to applications, we'll be having a separate playlist on machine learning, which will be dealing with not the traditional machine learning which is available on YouTube, but the machine learning which actually has the mathematical meaning. We will solve everything. We will even solve the linear regression model from scratch, and we will check how the linear regression, that line comes, and that line is known to be the best fit line. So we will be solving every each and every detail. We would solve optimize big loss functions with the help of linear algebra, with the concepts of linear algebra and optimization. And it is going to be like a fun thing to do. And actually, I made this course because I realized that there is no Indian content creators or no Indian educators who are actually teaching this machine learning and deep learning things in mathematical way in India. So everywhere it's just those some frameworks like PyTorch and TensorFlow to create some neural networks, but actually that has got a huge mathematical depth to it. And this playlist will not be for people who are just studying it one day before the semester exams, because this is not the purpose of the playlist. Its purpose is solely to make people understand the core of linear algebra, the core of machine learning and deep learning mathematically, so that you can solve any deep learning or machine learning problems. You can actually frame the problem mathematically. Once you frame the problem mathematically, the solving becomes very easy. It's just there are some steps to do and then you just get the solution. But framing of the problem is what makes you a good machine learning or deep learning engineer. So this is just going to be the first video, and we'll see you from the next video on linear algebra.